This presentation is about how to conduct an analysis of covariance, or Ancova. This is essentially an ANOVA that considers a confounding variable. As you look at the data set, you already can determine that it is a small data set. And by groups, drinks is the factor with 3 different levels. You can confirm that by clicking on variable view and clicking on the values. You will see that drink has 3 different groups. 1 is water, 2 is Lucozade, which is apparently an energy drink in England, and then our regular cola. So we can click on this and go back to the data view. We can see that for each one of these there's about 5 participants. 5 participants and 5 participants for the other group. So because it's a small data set, we're not necessarily going to run our test for normality and so forth. We will simply conduct the test of assumptions which are required for an analysis of covariance. And these are homogeneity of the regression slopes and a test for independence. So my recommendation is that to run a homogeneity of regression slopes, you simply conduct a scatter plot, a simple scatter plot, define it, enter the variables of interest. I actually ran this a little while ago, so let me go ahead and reset this. Your y-axis is going to be how well a person feels. How drunk will be your x-axis, and you will divide this by the drink on your rows. So this will create subset of scatter plots for each one of the different drinks. We can click on OK, and now we have this graph that's been divided into 3 different scatter plots by the type of drink: water, Lucozade, and cola. To determine the regression of slopes, you can actually click on the line of best fit, close, and close, and now we can see that the regression slopes are similar for water and Lucozade, but not necessarily for cola. This could potentially tell us that there is a problem or a violation of the regression of slopes assumption of the Ancova. We will proceed, however, with the analysis. There's no way necessarily to correct this. Likely what is happening here is that we have a very small data set, and as you can tell, some data points are piling up over here. If you notice, you have 1, 2, 3, 4, 5 data points here. 1, 2, 3, 4, 5. It's 5 per group. And here you have 1, 2, 3, 4, 5 are actually piled up over here, which is showing that there's not that much variance in this group. And so that is causing this regression slope to ascend rather than to descend. So that is the test of regression of slopes, and that's actually a visual test. The test for independence is conducted by running an analysis of variance, where you compare means for the different groups. And first, let's bring in the factor, the categorical variable with our 3 different levels, and how well a person feels into the dependent list. Let's review the research question. The researcher is interested in telling if how well a person feels is affected by a drink that they drink in the morning after. So if a person has been to a party and consumed alcohol, how well do they feel the next day after consuming water, Lucozade, or Coca-Cola to recover from the hangover? And so our tested dependence should show that there is no effect for our dependent variable and our independent variable, in this case, the 3 different drinks. Now, more importantly, when we're looking at independence, is to determine whether there is an effect on the drink and the covariate. In this case, how drunk the person was the night before. So in the research question that says, how well does a person feel after drinking a recovery drink, this researcher is saying, you know what? There could be a covariate here, or a confounding variable, which is however drunk a person got the previous night may have an effect on how well they feel. If drink and how drunk a person got the night before are significant, or drink has a significant effect on how drunk a person was the previous night, that would demonstrate dependence. However, we want to demonstrate independence, and so therefore there should be no effect on this ANOVA in particular. So click OK and look at the result. On the first ANOVA, how well does a person feel, and the groups, we saw that it was not significant, so there was no effect. And on the second group, again, there was no effect, and there is actually no effect, this is larger than 0.05, on how well the drinks that a person has consumed and how drunk the person was the previous night. So now interpreting these two in a generally linear model will be more accurate. If there had been an effect of this, in other words, if the drink a person drunk to recover and how drunk a person was the night before, if this had an effect, it would be very hard to answer our research question, which is how well does a person feel after consuming a recovery drink. So let's go ahead and conduct the general linear model, or the Ancova. So we click on general linear model, univariate. Univariate means that we have one dependent variable, and that dependent variable is how well a person feels. Our fixed factors in this case is drink, right? The categorical variable is a factor, and it has three levels, the three different drinks. We have a covariate. The covariate is how drunk was the person the night before. And so we enter that into the box with the covariate. So the research question again is, how well does a person feel after drinking a certain recovery drink, water, Lucozade, or cola, the next day? However, there could be a covariate, that is, how drunk was the person the night before, that might affect this entire analysis. As we bring the covariate in, we may be able to tell if there is a confounding effect on the research question that we're attempting to answer. Let's go ahead and run everything that we need to do here. In this case, we have a drink with three different levels, and we'd like to see a simple contrast between the three different levels. That is the difference between Lucozade and water, or between Coca-Cola and water. So we can click on first for water, because water is always first, the most healthy drink. Click on continue. And then we're not necessarily going to click on plots. We're running a full model. No need to click on this. Eventually we can, but not in this case. We're not going to save anything, even though you could save some cook distance and leverage values that would act pretty much as coefficient and regression analysis works. So let's click out of that. In options, let's bring in drink. Let's see the means for drinks, and we can compare the main effects with an LSD. And let's ask for descriptive statistics, estimates of effect size, homogeneity test, because ANOVA requires a homogeneity test. And let's ask for parameter estimates, which will allow us to interpret the data better. Click on continue, and now you're ready to actually run the entire analysis. Let's click on OK. So the first thing that happened was we saw that there was no effect independently for the type of drink that was drunk and how well a person felt. There was also no effect for the type of drink the person consumed the next day and how drunk the person was the previous night. So it's determined that these were independent. And in the case of the univariate analysis, or the Ancova in this case, because we've entered a covariate, this is the output. We have 5 participants that drink water, 5 that drink Lucozade, and 5 that drink cola. These are simply the between subject factors or the participants for each one of the groups. The mean for how well a person felt for water is 5, for Lucozade is 5.8, and for cola is 5.8, so pretty much these are similar. There might be something going on here. This is an eyeball estimation. We can't really say anything about this. Do we have a violation of the homogeneity of variance assumption? No, we don't, because this is significant, suggesting that the homogeneity or the variance of each one of these groups, water, cola, and Lucozade, are similar. Therefore, we can interpret our data without problems. Let's look at our test of between subjects effect. So what we're looking for now is whether the drunk, how drunk a person was, and the drink that they consumed the next day after as a recovery drink are indeed significant or not. Do they have an effect on how well a person feels the next day? So if we look at drunk, all of a sudden drunk, we see that emerges as significant. And drink also emerges as significant, suggesting that when you are measuring how well a person feels the next day after consuming a recovery drink, water, Lucozade, or cola, it's important to consider how drunk the person had gotten the previous night, because each one of these emerges as significant. The model is now significant. You can see that there is much more variance that is accounted for, and you can actually see that by comparing it with a variance that was accounted for previously between groups 2.1, between groups 8.4. Now we're looking at drunk 11 and drink 3. So this is a much larger variance accounted for. And now we have parameter estimates. This is what emerges. When you look at the parameter estimates, consider that you're looking at the coefficients of a regression analysis. We look to see if any of these estimates is significant. And we can see that drunk, or how drunk a person was the previous night, is significant. Now we're going to interpret it. This means that how well a person feels when everything else is equal to 0, how well a person feels is 7.11 on a scale of 1 through 10, let's say. And how drunk a person got the previous night will result in a half-point reduction of how well a person feels the previous night. In the case of drink, we have significant parameter or predictor, drink number 2, which is actually Lucozade, as significant. In this case, what we can see is that by consuming Lucozade, you will feel almost 1 point better the next day. As your recovery drink, we would recommend Lucozade. Well, obviously we're not recommending that, but in the case of this study. Estimated marginal means is the mean response for each factor adjusted for any other variable in the model. So the previous means were 5, 5.8, and 5.8. When you consider the means for these groups, water, Lucozade, and cola, with the covariate of how drunk a person was, the well-being score for a person, how well a person feels the next day, is actually adjusted. So for water it's 5.1, for Lucozade it's 6.23, and for cola it's 5.25. So we can see that Lucozade appears to be the champion. Let's see where the difference is radicated in the pairwise comparison. Water versus Lucozade is significant. So Lucozade is a better choice over water, we could conclude. How about water and cola? Not statistically significant. So whether you drink water the next day or cola may not have an effect on how well you feel. We could also compare Lucozade and Water, we already determined that was significant. And leukocyte is actually a lot better than cola because it's also emerging as significant. And this is the mean difference, which is our parameter estimate, matches with the parameter estimate. So the purpose of the Ancova is to answer a research question for a regular ANOVA considering a confounding or a covariate. In this case, we can conclude that when you consider how drunk a person was the previous night, then there's a difference in the type of recovery drink on how well the person feels the next day. And that concludes the presentation for analysis of covariance.